Alright guys, so we're going to be working on the worksheet domain and ranges from word problems. So it's pretty much what we did yesterday, just more in detail today. So who wants to read the first one? Go ahead.
Okay. Joe had a summer job that paid $7 an hour, and he worked between 15 and 35 hours every week. His weekly salary can be modeled by the equation S equals 7H, where S is his weekly salary and H is the number of hours he worked in the week.
Good. So just like yesterday, the things that you're going to want to do as you read are circle any equations that it gives you, underline anything that defines those variables, like S is equal to salary, H is equal to hours. So make sure you underline those. And then if there's any restrictions, like between here or here, maximum of this or minimum of that, in this case between 15 and 35 is what you're going to want to underline. So now the first question says to describe the independent variable. Now independent, is that X or Y? X. So every time you see independent, put an X. So in this case, is X, our independent variable, going to be hours or salary?
Hours.
Good. So it is the hours what? What is he doing?
Work.
Hours worked.
That's it, the answer?
For part 1, yes. To be exact.
To be exact.
Okay. Describe the domain and range. So just like yesterday's assignment, for domain, label it. Is it hours or salary? Hours. So put the word hours above it. And our range is going to be the other one, which was salary. Now, the only thing it didn't ask us today, which yesterday's worksheet asked us, is this continuous or is this discrete? What is that going to be?
Continuous.
Continuous, good. And it's going to be continuous because it's hours, and time is always going to be continuous. So for continuous functions, I'm just going to write continuous right here. Anytime you have continuous functions, your domain and your range will always be written with alligators. Domain is X, range is Y. So now, our hours, what is the least amount of hours that he can work?
15.
15. So we put 15 first. And what is the most?
35.
35. Bless you. So now we need to find the salary, which is our range. If I work 15 hours, how can I find out how much I earned? What would I need to do? Multiply by what number?
7.
Good, which is our equation up here. So 7 times 15 is
7 times 15 is... What is your
Bless
5?
you. Say it again.
What is your 5?
105.
Yeah.
So that's our first number. And now our second number, which is 35, we're going to do the same exact thing. 7 times 35. Put that in your calculator. 345?
245.
245? And we're done with part 2. So yesterday's worksheet, we finished and we stopped right there. So today we're just going to add one more step to it. In this case, it's the third question. What does each value in the ordered pair mean in context of the problem? Well, 20, is that the X or the Y?
X.
And what does X stand for? Hours or salary?
Hours.
And the 140 is our,
Salary.
good, our Y, which is salary. So for working, make a sentence out of it. 20 hours Joe earned or made how much money? Use that point. 140 puppies, gum, $140. Alright, are there any questions on this problem at all? Okay. So I'm going to let y'all finish copying this down. Are we done copying it down?
Yes.
Okay. Let's go on to the second problem. So who wants to read the second one? Go ahead, Jackie.
Hector's Service Club is raising money by wrapping presents in the mall. The function fx equals 3x describes the amount of money in dollars the couple earns for wrapping X presents. They only have enough wrapping paper to wrap 1,000 presents.
Alright. So X is for presents. The f of X, which is our Y, is the amount of money in dollars that they earn. So which one is our dependent? Is dependent our X or our Y? Y. Independence X, dependence Y. So what does Y stand for? X is present, so Y is money for presents, right? Alright, so from those two, or from that, what is going to be our domain? The presents or the money? Presents, good. And then our range is going to be the money, which is our Y. Good. So now we need to determine, is this continuous or discrete? So the way to look at it is look at your domain. Can you wrap half a present? No. If you go and you're taking something to get wrapped, they either wrap it all or they don't wrap it at all for you, right? So it's an all or nothing. So that would be discrete. So I'm going to write discrete right here. Now, unlike continuous, we're not going to use alligators. We're going to list out our numbers. If you're not good at drawing your mustaches, put parentheses with a little curve on it. A Christmas tree.
I don't know.
So what is the least amount of presents that they can wrap possible?
1,000.
That's the most.
Oh.
The least amount, the smallest amount. Zero, good. Because maybe they were really, really bad at wrapping presents and no one wants them to touch their presents. Now, what's the most?
1,000.
1,000. And they gave us that in our word problem. So, looking at our equation, y equals 3x. If I put 0 in for x, how much money are they going to make? 0, right? Because no one's going to pay them. Now, if I put 1,000 in for x, 3 times 1,000, what am I going to get? 3,000. Good. And we're done with that one. So go ahead and flip it over. Is this problem continued or is it the same? Or is it a new problem?
There's a new problem.
Alright, so this problem is very similar to the one from yesterday. So, go ahead. Who wants to read this one? Go ahead.
The surface area of a cube can be found using the following formula. A equals 6s squared, where A represents the surface area of the cube and S represents the length of one edge. Your geometry teacher wants you to draw a cube that has a length of at least 5 inches.
Okay. At least 5 inches. That's the minimum. So the number's different than yesterday, and they're asking us for a little bit more. So describe the independent. Independent is what? X or Y? The X. So in this case, would that be area or side length? Side length. The way you can tell is your X, your domain is always inside the equation. So this is the side length. So that's our domain. I'm just going to put the word side. What is our range? It's going to be a variable.
No.
We already did side length.
I mean the surface area.
The zone area. Now, looking at the side, is it possible to have 5.2 inches or 5.5 inches? Yes, you can have decimals in there. So if decimals and fractions count, what are we talking about? Discrete or continuous?
Continuous.
Good. So, from continuous, how do we write those? With alligators or with the little mustaches?
Alligators.
Good. So now, what is the least amount?
5.
Good. Do they give us a maximum? No, so what would we put mathematically? Infinity. Now, if I was to put infinity into that equation, will I get an exact number? No. So what should I put? Infinity. Because it's just going to keep getting bigger and bigger and it just doesn't stop. So I need the last number, the range, the y value for 5. How do I find the area if the side is 5?
The formula gave you.
Use the formula they gave us. So 6, 5 squared. What is 5 times 5? 25. And then use your calculator or your head, whatever. 6 times 25. Say it again. 150? And we're done with problem 7. Alright, number 8. Find an ordered pair that represents a reasonable input-output, so an x and a y, for this function. So, and then describe what it means. So, any number, any side length that's bigger than 5 but less than infinity. 6? Okay. So 6 comma, now we need to find that y value. So use your formula. What is 6 times 6? And then 6 times 36.
6 times 36.
260? Now, is this the only possible number that we could use? No. As long as the number was bigger than what? 5. Could I have used a decimal 5 point something?
Yes.
Okay. So, what does that point mean? Give me a sentence. If the side length is...
Okay.
Okay.
you write that?
Uh-huh. This is the description. If the side length is 6 inches, then what? What's the other variable?
216.
That's the number, but what does that number represent? Area. Then the area is 216. And we're done. Alright, last problem. Ready? No? Okay.
A ball is thrown into the air with an initial velocity of 70 feet per second. The height of the ball after 2 seconds will be measured by 8 equals 72 feet minus 60 feet. The depth of the function is going to the right.
Alright. So describe the dependent. Is that our x or our y values?
Or Y.
The y. So looking at our graph right here, is time or height the y?
Height.
Good. So we'll put the height in feet of the ball. Now, why do you think this graph curves? Exactly, because it comes back down. We throw it up, it's going to come right back down. So, describe the domain and range. Are these dots all connected? Yes. So that means it's going to be continuous, which means I use alligators. Now, only looking at our x, how far left does this graph go? And how far right does this graph go?
4.5.
4.5. Now, our range talks about what? X or Y? Y. So bottom to top, how far down does this graph go? And how far up? Up?
120. Oh, 80.
It's above 80, less than 90, 82, 83, anything around 82, 83. I'm going to put 83. But I would accept 82. Alright, are there any questions on this? Ask now. No questions, you're just awesome at it. Okay, what is your homework this whole week? And notes.